Chemical equations represent a recipe that fully describes the changes in atom organization before and after a chemical reaction. Let's take a common example from a first-year lab accident. In this equation, we can find examples of most of the symbols we will encounter in chemical reactions. The S next to the sodium bicarbonate stands for solid. The cursive L next to the water molecule stands for liquid. The G next to the carbon dioxide molecule stands for gas. The AQ next to the hydrochloric acid stands for aqueous. Aqueous is just a fancy way of saying dissolved in water. And finally, we have this arrow, the yield sign. This is our separation in between reactants and products. It separates the before the reaction happens to the after the reaction happens. In the future, we will also encounter other symbols in chemical reactions that are like the yield sign. For this one, with the double arrowhead, this means a reversible reaction. But that's for another day. Here's another example of a balanced chemical equation. In these types of equations, we have the same number of each type of atom represented on both reactant and product sides of the equation. The numbers of atoms can be represented in several ways. The subscript 2 on the ethanol molecule represents 2 carbon atoms. The coefficient 2 in front of the carbon dioxide represents something totally different. That means that we have 2 separate carbon dioxide molecules on this side of the equation. It also implies that we have 2 available carbons from those 2 carbon dioxide molecules. Please note that subscripts tell you how many atoms are within a molecule, and a coefficient tells you how many molecules you have in the balanced chemical equation. This last example of a precipitation reaction gives us a perfect example of how to count atoms. Let's focus in on the aluminum nitrate. The parentheses indicate a cluster of atoms that repeat in this pattern the number of times that the subscript next to them indicates. This means that I have 1 aluminum in this formula and 3 nitrates. However, for atom counting purposes, the coefficient 2 means we have double the quantity of this entire formula. So we will have 2 aluminum atoms, 3 times 2 nitrogen atoms, so 6 total nitrogen atoms. 3 times 3 times 2 for the oxygen to account for that subscript 3. So that means 9 times 2, or 18 oxygen atoms, for our total atom count from that particular species in the balanced chemical equation. I hope that this overview of symbols used in chemical equations will help you be more successful at balancing equations and using appropriate values in your future stoichiometry problems.